Alright, ladies and gentlemen, welcome to video 3 of 5 for your Chapter 4, Section 3, Algebra 2 notes. This video is going to cover how to factor a trinomial when a is equal to 1. In other words, the number in front of the x squared is equal to 1. This type of factoring is what we're going to do anytime that we have exactly 3 terms. The coefficient on our lead term, that's the x squared term, is positive 1. And when we can find two factors that multiply to c and add to b. So here's what we mean by that, okay? They need to multiply to 20 and add to 9. So there's only a certain number of, sets of numbers that multiply to 20. 1 and 20, 2 and 10, 4 and 5. You've also got negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. Now, no matter which two you're talking about, if you add those numbers together, they all have a unique sum. We want the ones that add up to positive 9. So that would be positive 4 and positive 5, which means x squared plus 9x plus 20 can be factored into an x plus 4 and an x plus 5. Same thing here on the next one. We need two numbers that multiply to 12 and add to negative 8, which means the same sign, they're both negative numbers. So the numbers that multiply to positive 12 and add to negative 8, you got negative 1 and negative 12, but those add to negative 13. You have negative 2 and negative 6. Those are the ones that we want, because those are the ones that add to negative 8. Or negative 3 and negative 4, you add those together to get negative 7. So your two factors of this trinomial would be x minus 2 and x minus 6. There are two more examples in your notes. We're going to go through those again real quick. We've got two numbers that multiply to negative 15 and add to positive 2. If they multiply to a negative number, one would have to be positive and one would have to be negative. So no matter which numbers you're talking about, you want the pair of numbers that multiplies to negative 15 and adds to positive 2. That would be negative 3 times 5. Negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. So our two factors are x minus 3 and x plus 5. Same thing here, we need two numbers that multiply to negative 18 and add to negative 7. That would be 2 and negative 9. So x plus 2 and x minus 9. So we're going to go through these examples. You probably should pause the video now and try them on your own and then resume the video to see how you did. Looking for two numbers that multiply to 24 and add to 14. Okay, we need two numbers that multiply to 24 and add to 14. Well, that would be 2 and 12. So that factors into x plus 2 and x plus 12. Okay, on the next one, we need two numbers that multiply to 54 and add to negative 15, which means they are both negative numbers. That would be negative 9 and negative 6. So that would factor into x minus 9 and x minus 6. Letter C. We need two numbers that multiply to negative 21 and add to positive 4. Well, negative 1 and 21, that's not going to work. That adds to 20. It's way too big. Negative 3 and positive 7, there's the set we want. Negative 3 and positive 7. So that factors into x minus 3 times x plus 7. And then on letter D, two numbers that multiply to negative 30 and add to negative 7 would be negative 10 and positive 3. So that factors into x minus 10 and x plus 3. Now, E and F are examples of solving. Once again, it needs to be equal to 0 in order to be solved. So then we would factor the left side of the equation. So we're looking for two numbers that multiply to 44 and add to 15. Well, that's 4 and 11. So that would be x plus 4 and x plus 11. Since that is equal to 0, that means that our answers are x plus 4 equals 0 or x plus 11 equals 0, which gives us possible solutions of x equals negative 4 or x equals negative 11. Okay, again, we would solve those individual equations, subtracting 4 from each side and subtracting 11 from each side. Same thing on letter F. We need two numbers that multiply to negative 48 and add to positive 8. That would be 12 and negative 4. So this factors into x plus 12 and x minus 4, which means our possible solutions are the solutions to the equation x plus 12 equals 0, or the equation x minus 4 equals 0, which would be x equals negative 12, or x equals positive 4. All right, so that takes us through trinomial factoring. We are going to go a little bit further here because there are more problems to do. I will point out that both J and L are missing information that you need in order to do the problem. So we will not be showing those two problems in this video. On letter G, it is not equal to 0. So our first step is we need to move the 24 to the left side of the equation so that the equation is equal to 0, because we cannot solve by factoring until one side of the equation is equal to 0. Then we need two numbers that multiply to negative 24 and add to positive 10. I'm sorry, negative 10, which would be x minus 12 and x plus 2. That means our possible solutions are x minus 12 equals 0 and x plus 2 equals 0, which means our possible solutions are x equals 12 or x equals negative 2. Same thing on letter H. We need to move that x so that it is in the middle. Okay, we need to rewrite that expression as x squared minus x, which would be 1x minus 20 equals 0. Then we need to find the two numbers that multiply to negative 20 and add to negative 1. Well, that would be negative 5 and positive 4. Each of those factors gets set equal to 0 using the zero factor theorem. And then we solve those equations to give us our solutions, x equals 5 and x equals negative 4. I and k are examples of SAT questions. It says in the xy plane, the graph of the function f of x equals x squared plus 10x plus 9 has two x-intercepts. Again, as soon as we see the word x-intercepts, we should think 0 solution root as well. So what it wants us to do is it wants us to solve the equation 0 equals x squared plus 10x plus 9, which would be done by factoring. Two numbers that multiply to positive 9 and add to positive 10 would be 9 and 1. Which means the solutions would be x plus 9 equals 0 or x plus 1 equals 0, meaning solutions of negative 9 or negative 1. Now, when we're looking at the graph, what that tells us is that our graph of our parabola passes through the x-axis at negative 1 and negative 9. It's asking us for this distance between those 2 points. That distance would be 8 units. So our answer here would be there are 8 units between x equals negative 9 and x equals negative 1 on the graph. Okay, then we have the product of two consecutive positive integers is 55 more than their sum. So the word consecutive tells us that our two integers are x and x plus 1. That's like 4 and 5. 4 and 5 are consecutive integers. So if we don't know the first integer, but we know that the integers are consecutive, the first integer is x, the second integer would be x plus 1 because it would be the next integer. It says the product, that means multiply, of two consecutive positive integers, that's our x times x plus 1, is our equal sign, 55 more than their sum. That would be x plus 1. So we would distribute here, which would give us x squared plus x. And on the other side, we would combine like terms, which would give us 2x plus 56. We then need to move everything to the other side of the equation. So subtract 2x and subtract 56 from each side. That would give us x squared minus 1x minus 56 equals 0. We would factor. Two numbers that multiply to negative 56 and add to negative 1 would be x equals negative 8 and x equals positive 7, which means either x minus 8 is equal to 0 or x plus 7 is equal to 0, meaning our possible solutions are x equals 8 and x equals negative 7. Now the word positive appears in the problem, which means x equals negative 7. That gets thrown out because it's not positive. So x is 8. So our two consecutive integers are 8 and 9. And the bigger of those two integers would be 9. Okay, our final screen here for this video involves two more word problems. Letter M says the equation below gives the height of an object above ground y in feet t seconds after it is launched from a platform. How many seconds after it is launched does the object reach the ground? Well, again, the ground is y equals 0. So it's saying plug 0 in for y and solve for t. Now there is a greatest common factor here, and that greatest common factor is 16. So I'm going to factor out a negative 16, which would leave me with t squared minus 4t minus 5. That trinomial factors again. Numbers that multiply to negative 5 and add to negative 4 would be negative 5 and positive 1. Meaning that my solutions would come from t minus 5 equals 0, or t plus 1 equals 0, t equals 5, or t equals negative 1. Now these are the times when the graph of this function would cross the x-axis. Now this ball was launched from a platform, and time was 0 at that point. So time really can't be negative, which means we're really going to throw out the negative answer here. And the answer to the question would be the ball would reach the ground after 5 seconds. Letter N is very similar. It says a person throws the ball upward from a 506-foot tall building. The ball's height in feet, h, after t seconds is given by the equation h equals negative 16t squared plus 48t minus 506. The ball lands on a balcony that is 218 feet above the ground. How many seconds was it in the air? So 218 is the number that we plug in for the h. So we end up with this equation to solve. Now if we're going to solve that by factoring, it has to equal 0. So our first step is to subtract 218 from each side of the equation so that one side of the equation will equal 0. That would give me 0 equals negative 16t squared plus 48t plus 288. Then I would factor out the greatest common factor. The greatest common factor is 16. So I'd take out negative 16, which would leave me with t squared minus 3t. Oh, I don't know. What's 288 divided by 16? 18. Minus 18. Again, that trinomial, t squared minus 3t minus 18, that would factor again. Numbers that multiply to negative 18 and add to negative 3 would be t minus 6 and t plus 3, which means you're looking at t minus 6 equals 0 or t plus 3 equals 0, which gives you your solutions of t equals 6 or t equals negative 3. Now again, we're going to throw out the negative answer because time in the context of the problem, time cannot be negative. So the answer here would be 6 seconds. That does it for our third video. There will be 2 additional videos, one to discuss difference of 2 perfect squares and one to discuss factoring trinomials when a is not equal to 1. Thank you very much for your time and attention.